Does that change that? No?
Yeah, it's better.
Oh, that's better? Okay.
I can hear you now.
I thought I had changed some things about how the microphone was set up. Turned out I had not. So so thank you for letting me know that I was not making any sound. That would be awkward. Be a long hour. So is everybody surviving their first week of online instruction by some definition of surviving?
I had to take a
Say
calc
it's-
test through email.
Ooh.
Yeah.
So like they emailed you the test and then you emailed the answer back?
They
Or?
they emailed us the questions, and then we had to do the work on a piece of paper and either take a picture of the paper or type it all out into the email.
Wow.
That sounds awful.
It does
was
sound awful.
It was really weird.
Yeah. Ooh. Yeah, I think timed exams and quizzes are just there's a lot of faculty conversation about like how to make that work, and everything I hear does not sound good. I mean, it just all sounds really awkward and strange, and I'm not a fan. And yeah, I don't know. Not my thing. We're not going to mess with that because I just don't see that that's useful. But that's my opinion. Other people's opinions may differ, and that's fine. So we should go ahead and start. The Chapter 8-9 quiz was due last night. But if you had any issues, technical or otherwise, definitely let me know. I can give you more time or give you another go if you've used all three attempts at the quiz. So if you've had problems, let me know. I'm happy to sort of try to extend that, spread that out some. I just wanted to quickly mention the booking office hours thing, just in case people were unclear on how that worked. I meant to say something about this Wednesday and I forgot. So I'm going to switch over to, this is the actual thing you would get if you click on the link that I posted on Canvas and on Slack to making an office hour appointment. It would pull up a calendar like this. All this blue is my calendar. You wouldn't see that, and you would see your calendar if you're using Google Calendar. And these gray appointment slots, and you can move forward, like this is today. If you wanted to move forward to next week, you could do that up here. And there are some appointment slots Monday, for example. And if you want to grab an appointment slot, just click on it and you'll get this little interface, and you can fill out stuff and hit save, and it'll send me an email and everything will be good. So you can use this to grab slots, and you could, if you wanted to, you could run ahead and grab a slot for mid-April. I don't know why you would want to do that, but you could. So that's a useful way to try to set things up. I may add some more appointment slots. I'm still figuring out what I can cancel and what needs to stay on my calendar as we move forward. I'm trying to cancel as many things as I can, frankly, but there are definitely things that need to stay put. And so I'm sort of working through that as we go, but I tried to put in as many appointment slots as I could. Questions about that business? We good? Okay. And then I was curious, like, how are people doing on the homework? Have you, started it and it looks okay? Are you just haven't even looked at it because life is like that right now? Have you, whatever. So really, are there any questions about the homework? But it'd be nice to know, like, the difference between there are no questions because no one's looked at it, and there are no questions because it's really obvious and nobody had any problems. So are we doing okay? How are
Yeah.
things going?
I looked at it a little bit last night. The first couple seem pretty. I was able to kind of figure those out.
Okay.
But I was struggling with the third problem.
Okay.
I'm not quite sure where to start on that one.
The third problem. Now I got to go find my. So, do you mean exercise 9.5, the monotonicity of for all problem?
No, it's the exercise 9.9.
On to the next one. Yeah. So, okay. Oh, it is still monotonicity of for all. I just labeled. Yeah. Okay. So what I would do on 9.9, so actually let me pull up the whiteboard so I can draw, and and I should have the tablet ought to be working again today, because I think I dealt with my technical problem from before. Exercise 9.9 is theorem 9.12, monotonicity of for all. And the theorem says for all x r q implies p implies, and actually I'll write that sort of down here, it implies another implication, namely that if we know for all x q, that implies for all x r p. So this is saying if we know this part, then we know this part, that this quantification implies that quantification. Is that the correct problem, Cole?
Yeah,
Okay.
that looks right.
So this is, I think the start on this problem is tricky. But once you sort of figure out the start, the rest of it's not too bad. And I think the first step that I would do is actually shunting as a big hint. 3, 6, 5, shunting. And if you remember correctly, shunting says, that P implies Q implies R can be rewritten as P and Q implies R. And in this case, like this piece here is P, this here is Q, and this is R. So it has that structure of a thing implies an implication. So a thing implies an implication. And so we can rewrite it, go back to black, we can rewrite it as then for all x, R, Q implies P, and the left-hand side of that implication for all x, R, Q, that implies for all x, R, P. And at this point, you've got a for all and a for all. And there are chapter 8 rules that let you join those together into a single quantification. And then you'll end up with some stuff in the body of that single quantification that you can use some chapter 3 rules on And then, oh, actually, sorry, I started with, after I did shunting, you could then try to prove that all of this is true. I actually chose to start with the left-hand side here, oops, and then show that that implies this, but you can do it either way. But essentially there's a chapter 8 rule that lets you join these things together. And then there's a chapter 3 rule that will let you combine the Q implies P and the Q, and then things will play out from there. I don't know if that helped any.
No, that helps a lot. I think it was just the having two implication
Right.
operators in there that was throwing me off.
Yeah, no, I think that's definitely confusing. And I bet there's a way to do it without shunting, but I don't know a good way to do it without shunting. And I find that if I do shunting, then it allows me to do things with these two that are kind of straightforward, and make me happier. So yeah, I think that using shunting in the first step is the non-obvious but important part, for me at least, in solving the problem.
All right, thank you.
You're very welcome. I am here to provide hints. Other questions about the assignment or anything we've done so far?
So I was wondering on 8.7a, which is actually from the one that we moved from the last assignment.
Yeah.
If you end up having like even.I and odd.I, can you change that to I? Can you change that to just I, or do you have to do
No. So if you had if you have even dot I and odd dot I, you're saying that I is even and I is odd. Now, is that possible?
No, so can you change it to false, or?
Yeah, that would be false, because a number cannot be both even and odd. Similarly, if you ever have even I or odd I, that's true, right? Because every integer is either even or odd. So we know that that is true regardless of the value of I. And we know that this is false regardless of the value of I. Did that help?
Yeah, thanks. I was just wondering if you could change it without having to do any proofs or anything, if you could just change it.
Oh, you could just rewrite this, and you could say, like, for both of these, you could say kind of by arithmetic, if you want to, like, how do I justify that? Because again, we don't have a theory of integers and a theory of even and odd. So this is a place where we're just going to pretend that we remember all of the math that we've learned in the previous however many years that we've been learning math in our lives. And so you could just be like, by arithmetic, and move on.
Okay, yeah, thanks. That helps.
Not a problem. Other questions? Going. Gone. Okay, so find my notes. Oh, and then I wanted to talk about the timing of the exam a little bit. So I posted some notes on Canvas and on Slack about this, but in an office hours conversation with a student, I realized, and I had just not thought about this, but I realized the timing of the exam, I guess I could say stop sharing. The timing of the exam matters for the, it potentially matters for people who are going to be making decisions about whether to switch their grade basis or just straight up drop the course. So you have until the 17th of April to make those changes. Normally, those kinds of decisions would have need to have been made weeks ago. But because of the special circumstances, the university is extending that deadline to the 17th of April, which is like several weeks from now, 3 weeks from now. But given that the exam's going to take a week if we do a take-home thing, and then I've got to have time to grade it for it to be of any use to you, we need to be thinking about that. And so I had been thinking of maybe pushing the exam into the future a little bit, but I hadn't thought about how that would interact with this deadline. So I'm now, and Emma in particular, you've asked about this a couple of times, so I would love to hear your thoughts on sort of whether this is going to make things worse for you in some way, and this applies to everybody. But if we stick to something like the original plan, which would be I would pass out the exam. Well, the exam was scheduled to be on the 3rd, which is a week from today. If instead I pass out the exam on the 3rd, and then I give you, let's say, a week on it, because realistically, I'm probably not gonna be able to start grading it before the weekend in a serious way. So if we say you've got a week, so it would be due on the 10th, then I would grade like mad over the weekend and try to get you your grade back on the 13th, maybe the 15th, but hopefully the 13th. And then that would give you that week to talk to your advisor, make decision, talk to One Stop if dropping a class makes a difference for your financial aid, for example. But it would give you 5 days to talk to people about whether it makes sense to change your grade basis, whether it makes sense to drop the class. And I'm definitely not trying to push anybody away. I'm just trying to give you as much flexibility as possible. So that's my inclination at the moment, is pass it out on the 3rd. It's due on the 10th. But if you see some terrible flaw in that plan, definitely let me know, because until Wednesday or yesterday, I don't remember when, I hadn't even thought about how all this interacts with that new deadline. So you may see something that I just didn't catch, and you should definitely holler if that's been the case. So does anybody have any questions, any concerns, suggestions about that at the moment? Okay, not hearing anything. Okay, so I'm going to take that as a sort of tacit assent that schedule seems reasonable. If you feel different, definitely send me an email or a message on Slack or something, probably soon, because I'm going to need to be making sort of formal decisions here in the not too distant future. Okay, so if there aren't any questions, I'm going to press on with a few examples. I was going to do 2 more proofs. Let's see, what time is it? Yeah, I think we'll probably get both of these proofs done. And then if time allows, we'll start in on the translating from English to quantifications. So the kind of the first half or 2/3 of chapter 9 is the proofs about for all and exists. And then the last part is how sort of a revisiting some of the stuff we did in chapter 5 about translating from English to logic, and chapter 2, I think it was, translating from English to logic. Now we'll come back to that, but in the context of quantification. So we'll look at how we capture ideas that are presented in English that translate to quantification style statements, and vice versa. So if there's time, we'll start some of that today. So questions about anything before we start? Okay. Back to the whiteboard. So the first example I was going to do was exercise 9.20. Now this is, this is a long proof, and it almost certainly isn't going to fit on a single page and still be readable. So I'm just giving you a heads up. That's the first time that will have happened. And it's a long, it's sort of vertically long, no, horizontally long, as well as a number of steps. So if it was really short, I could possibly sort of do 2 columns, but the statement is actually fairly long. So I'm going to need most of the width of the whiteboard. So we'll get halfway through the proof, and then we'll skip over to the next screen. And if you need me to jump back so you can see where we came from, definitely let me know. Okay, so exercise 9.20, which is distributivity of or over exists. And now we get the actual backwards E because I have the tablet, which is theorem 9.23. And that theorem says, provided not occurs again, so we have our friend the occurs check, not occurs X in P. So we'll assume that X, the variable X, does not appear in P. Then exists X in R with a true for the range. So there is some X that makes R true. That implies exists X R P or Q equivals P or exists X R Q. Yeah. Okay. So that's what we're trying to prove. And we're saying here that if there is an X that makes P or Q true and X doesn't appear in P, then we can pull P out and say P or there is an X that makes Q true. And we need this bit at the front because if this wasn't true, if there was no X that made R true, then this would be false all the time. And if this is false, exist becomes false. So this would be false if the empty range rule applies. Whereas here, this would not necessarily be false because if P was true, this whole thing would be true. So we need to know that this doesn't vacuously collapse to false, which is why we have this sort of precondition on the front of this thing. Because if without that, weird things can happen here. But with this condition, then we're good and we can pull the P out. So are we cool with the general setup before we do the proof? Okay, proof. Now, I feel like there ought to be a way to do this that doesn't involve writing the whole thing out over and over and over again, but I don't know what that is off the top of my head. And so that's kind of awkward. It's part of what makes the proof kind of long to write out. I'm going to actually pull up the theorems and share that because I want to actually look at like what might we do. Oh, do I not have? Oh, man, sorry. Theorems. Come on, open the theorems. Oh, really? There we go. Okay, I'm going to switch the sharing over to the theorem sheet. Be nice if there was a way you could hop between 2 sharings without having to like close one and open the other, but I don't know how to do that. So looking ahead or looking back at what we might use to prove this theorem, let's get back here. There's a chapter 9 rule that looks kind of promising, but the trick is how are we going to get there? So in particular, this chapter 9 rule right here looks like it would be useful. It's labeled distributivity of and over for all, and the thing we're trying to prove is distributivity of or over exists. So there's a parallel naming, which makes one think, ooh, that might be useful. It's got the exact occurs check that we need, so that's great. It means we can use this because we have already assumed that this is true, which allows us to use this theorem. And it structurally looks really similar. It's a something implies an equivalence where the P comes out of the body and into its own outside the quantification. So structurally, it looks quite similar. The big difference is that this has a for all and a for all and a for all, and the thing we're trying to prove has there exists in all these places. And so we need to somehow get from for alls over to exists. And to do that, we're almost certainly going to end up using some of these generalized De Morgan rules. So these generalized De Morgan rules are our primary way of converting for alls into exists. They tell us, for example, that if we have an exists, we can turn it into a not for all, and we have to negate the body. So it's important that you introduce both these negations and you flip the quantifier. People will sometimes do two of those three things, and that doesn't work. You got to do all the parts, or these are not equivalent. And then there's variations on it in 918 that are all pretty easy to prove, where and all of these can be proven pretty easily through just double negation. It's you apply this and then use double negation to clean up the extra negations. And so you've got that if you have not exists, that's for all. Oh, not exists where a not in the body, it's for all with the unnegated body. Not exists without the negation, you get for all with the negation. Exists with the negation gives you not for all without the negation. So all of these things exist, and they give us ways to convert for alls into exists and vice versa. And that's what we're going to need to do here. If we want to get to something that matches 9.7, we're going to have to do a lot of for all exists flipping. So essentially, we're going to take our exists, turn them into for alls, try to use 9.7, and then see if we can wrap up from there. That's the basic plan. So does that make sense as a general strategy? Questions about that? Okay, let's flip back over to the whiteboard. Okay, so you can see we've got our exists and our exists and our exist, and we're trying to turn those things into for alls. And you could kind of try to do them all in one step, like say lots of generalized De Morgan, and I'm not going to do that. I'm going to do them sort of one step at a time, which will make the proof longer, but hopefully it'll be easier to follow. And then if people have questions, there'll be more chances for people to ask questions. So we'll start with the whole thing. P or Q, equivals P or exists X R Q. And so I'm just going to start with the leftmost exist and generalize De Morgan it. And we'll just work our way through. So I'm going to use 9.17, generalize De Morgan. And 9.17 tells us that this exists can be written as not for all x, not r. Now the actual theorem has a range in here, and in all the generalized De Morgans, the range never changes. The only thing that ever gets negated is the body. So if this had, since there's no range listed here, this is really just the word true. And after generalized De Morgan, it's still just the word true. So we can still leave it out, and we should be in good shape. And then that will imply exists x, r, p, or q, equivals p or exists x, r, q. And if you look back at 9.7, this is actually very promising because this exactly matches the leftmost part of 9.7. So it's like awesomeness. We have managed to, in one step, make the left-hand side match what we're looking for exactly. So that's a good sign. Like, it gives us hope that this is a direction worth pursuing. So now I've got two more exists that I need to deal with. So I'll do them one at a time. So let's do generalized De Morgan again. And I'm going to abbreviate so that we're not here all day watching me write things. So this is going to stay the same. And, oh, hello, somebody. There we go. Thank you. Then we're going to, oh, I need to undo that. I'm going to apply generalized De Morgan to this piece. So I guess it might be worth noting that I did this the first step. Now I'm going to generalize De Morgan on this guy here. And that's going to give me not for all x. The range doesn't change. And I negate the body, p or q. And those parentheses are important because I'm negating all of p or q, not just p. And then equivals p or exists x, r, q, close, close. Okay, with me so far?
Yes.
Awesome. Love hearing that. Okay, so now we got to here. Now we're going to need to do generalized De Morgan again to get this guy. Whoa, didn't mean to do that. Sorry. To get this guy here sorted out. I'm going to actually try to squeeze that in at the bottom since nobody is sitting at the back of the room in this new world that we live in. I'm going to just be bad and try to get that in right down here. And you'll have to yell at me if you think I've gotten too small. 9.17, generalized De Morgan again. And this is the same. And this is going to stay the same. P or, and now we're applying generalized De Morgan to this guy. And so we get not for all x, r, not q. Close. There's another close over here, but it kind of drifted off the, well, here, I'll do that. I got a little crazy. So we have now used generalized De Morgan to convert all of the, oh, and I guess I should mark that this is that. We've now converted all three of the exists into for alls, okay? This part matches exactly what we want, so that's great. This part, however, not so much. We've got these negations in front of the for alls, and that's not cool. That doesn't match 9.7. And we have this or here with a negation in front of it, and 9.7 actually has an and here. Now that part's going to be pretty easy to fix because regular De Morgan from chapter 3, regular De Morgan, says that this is not P and not Q. We can push the not in. It'll turn the or into an and we'll have not P and not Q. So that's what I'm going to do first just because it's easy. And it might give me some hints as to what I'm going to do about these negations out here that are currently kind of in the way and causing trouble. So I'll bring this over to the next screen, which means I have to rewrite it because there's not a copy paste option that works here that I'm aware of. I'll bring this over to the next screen, and then we'll do that step, and then we'll try to figure out where we might go from there. So, okay. So make sure I remember where I am. So I'm right there. Okay. So, undo. Oh, that was weird. Okay. So now I should be good. So we're, continuing. So this is exercise 9.20 continued. And so we've got not for all x, not r, implies, apologies for that. Oh, I'm in the wrong place here. So I need not for all x, r, not P or Q quantity equivals P or and P, I don't know, P or not for all X, R, not Q. Okay, so I think that copies what I had before correctly. So now I'm going to use regular De Morgan to tidy up that body there, and that's 3 point, no, let's see, make sure I get my rule right. De Morgan. That's 3.47b. 3.47b, De Morgan. And I've got for all x, not r, so that doesn't change, implies not for all x, r. And so we're applying that here, and we're getting not p and not q. Close, so that rewrote that to that. Equivals p or not for all x, r, not q. Okay. Now we got to figure out how to go from here. 9.7 looks pretty similar now. It's got a for all and an and. Now it has an and here, and it has a for all. So the differences are it doesn't have this not here, it doesn't have this not here, and it has a for all there. Also, this needs to match this. And we've got a not P here, we have a regular P here. That seems a little awkward. And so a potentially promising option, like if we need this to be an and, De Morgan might be a way to turn an or into an and move some knots around in a useful way. So if there was a way to like apply De Morgan here, that might be kind of cool. Well, one option would be if we took this negation and we moved it to the other side. That's using like a very old rule, 3.11, but 3.11 said not P equals Q is the same as P equivals not Q, that we could slide the negation to the other side. So if we move this negation over here, it will have gotten rid of the negation that's in the way here. That seems like a win. And putting a negation here would open us up to using De Morgan, which might put the negation we want on this thing here, flip that to an and, which would be good. And then we get two negations here, and they would cancel out with double negation. So fingers crossed, that would actually be a reasonable thing to do. So I'm actually going to try that. I'm going to use 3.11 to move the negation over and then hope that things flow from there nicely. Now that's not, I think, an obvious step. I think that that requires some looking and thinking, and it probably benefits from looking at where we're trying to get to and realize that, oh, we need a negation here and we need to flip this. And then thinking, oh, De Morgan would flip the or to an and. Maybe we can, do that. And there are several ways you could have done the De Morgan part. And it kind of depends on whether the double negation is going to end up here or here. And I'll just do it one particular way, but there are definitely more than one way to do this part. So I'm going to use 3.11 to move the negation to the other side. So this is still the same. And now inside here, I'm moving this negation to the other side of the equivalence. So I now have for all x r, not p and not q, equivals, negation of the whole thing. That's really crucial. And one more. So if you just move the negation in front of the p, that's not going to be correct. You're negating the whole right-hand side. And we need that so we can use De Morgan to flip this guy here. So a lot has happened there. If there are questions at this point, definitely feel free to ask. Okay, moving on. So now I'm going to use regular De Morgan. So 347 B again. And I get not for all x, not r, implies for all x, r, not p and not q. And that's supposed to be a negation. It got a little weird. Equivals. Now I'm going to use De Morgan on this or, and I'm going to get not p and, so the or turns into an and. I negate the first argument, and then I negate the second argument. So I now end up with two negations on this for all. So I negated the p and I negated the not for all to get two negations, and I flip the or into an and. Okay. And now double negation gets rid of that. And then actually it'll turn out it matches 9.7. So double negation is 3.12. Double, can't spell, negation. And so we have not for all x, not r. Oops, that was an implies, and I lost the arrow. Implies for all x, r, not p, and not q, equivals not p, and for all x, r, not q. Whew. And that matches 9.7 with the p turned into a not p and the q turned into a not q. So there's actually a substitution there. So that's done by 9.7 with the substitution P and Q are replaced by not P, comma, not Q. But with that substitution, this matches 9.7 exactly, and we're finished. Huzzah. So that's a pretty long proof. That is a longer proof than most anything we've looked at, spanning 2 screens and filling them both. Questions about that? There's a lot going on there, so feel free to holler. So I'm going to, oops, up too far. So I think the tricky part in this is noticing that 9.7 is a good place to go. And the name of the theorem is a hint that that's reasonable. And the fact that 9.7 has a very similar structure suggests that that might be a reasonable thing. But then we're going to have to convert all these exists into for alls. Generalized De Morgan allows us to do that. And that's where we get to at the end of page 1. We've converted all the exists into for alls. And then we're left with basically the knots are in the wrong place. So we can't quite match 9.7 yet because the knots aren't where they belong. And so we've got to go through and use some chapter 3 stuff to move the negations around to get everything to eventually match. So we have 2 applications of De Morgan and 1 application of 3.11 to move the negation to the other side of an equivalence, and an application of double negation. So there's quite a lot of chapter 3 happening, but then we get it to match up with 9.7, and then we get to celebrate and go home. So, questions? That was a lot. If there are not questions, we will go on to one last example of a proof from chapter 9, which would be 9.25. And then we'll, if there's time, and there may not be, we'll start with translation. If there's not time, we'll pick that up on Monday. So, questions about anything before we continue? Okay. So, not hearing anything, I'm going to press on. Let's then look at exercise 9.25. And, you know, this is the last sort of example that I have scheduled, as it were. But obviously, if there are examples that you would like to see, or you have questions that relate to the homework or other things, definitely ask, right? Here we're going to prove the monotonicity of exists, which is theorem 9.27. And that is another one of these weird things where there's a little dangling bit at the front. So if we know that for all x, Q implies P, then exists X R Q implies exists X R P. So this tells us that if we know that for every X, Q implies P, and we know that some X makes Q true, then we also know that there's some X that makes P true. Okay? So if Q always implies P, knowing that somebody makes Q true tells us that somebody must also make P true. Okay? Questions about the setup? Okay, proof. So here I'm actually going to start with the right-hand side, and I'm going to aim for 9.12. Let me flip over. So remember what we've got here. We've got a for all implies exists. and I'm going to flip over to the theorem list. That looks pretty similar to 9.12 here. And again, it's got the same kind of name. We're trying to prove monotonicity of exists. Well, there's a monotonicity of for all. That might be useful. And it's got a for all Q implies P at the beginning, which is exactly what we have. So that's really convenient. And then the inside looks the same, except for they're for alls instead of exists. So that's really the only difference between the theorem we're trying to prove, 9.27, and 9.12 is that this has for alls here and here instead of exists. So it seems like this really ought to be a useful thing. So I'm going to actually start with the right-hand side of our thing and try to use generalized De Morgan to get us into for all land so that then we can use 9.12. So that's my battle plan. So stopping sharing, go back to the whiteboard, doing. Okay. So I'm going to start with the right-hand side, as I said. I'm going to see if I can avoid writing the whole thing out over and over again, like I did on the previous one. So, and since the left-hand side matches 9.12 exactly, I'm hoping I shouldn't have to manipulate it. So maybe I can get away with just having the right-hand side. So exists X R Q implies exists X R P. Now here, I would like to use generalized De Morgan to convert these guys to for alls. So I will. Let's actually do that and see what happens. So I'm going to actually use generalized De Morgan. Make sure I get the right number. Too many sheets of paper. There we go. So it's 9.17. And in an effort to keep this from running on forever, I'm going to do it twice. Once on the left side and once on the right-hand side in one go. So I'm going to have not for all X R not Q implies not for all X R not P. Okay? Are with me on that? Questions? Cool. Now, so I've got my for alls, but if I look back at 9.12, I've got this problem that I have the negations here that aren't in 9.12, and I've got negations in here that aren't in 9.12. That seems perhaps worrisome. So I can get rid of these outer negations pretty easily, though. There's a rule that we haven't used a lot, but which is sometimes pretty helpful, and this is going to be one of them. It's called contrapositive, and it's 3.61. And it says P implies Q, equivals not Q implies not P. So it allows us to reverse the order of the implication, but we have to negate both pieces. Well, that might be kind of a good thing here because we want to get rid of both of these negations. So this sort of matches the right-hand side of contrapositive, and so we can swap the order of these two things. And that might be a cool thing to do. So let's actually do that and see if that takes us in a useful direction. Okay, so equivals by 361, contrapositive is going to give us for all X R not P implies for all X R not Q. So we basically got rid of the two negations and we swapped the P moved to the left and the Q one moved to the right. Are you with me on that? Okay, now we got to figure out what we can do from here. Well, this is where we can use 9.12 because 9.12 says that an implication like this follows from a for all. Actually, I'm going to write 9.12 over here so that we have it, because I think it's going to get confusing if we don't. So 9.12 says that for all X, let me make sure I can see 9.12. For all X, R, Q implies P, implies for all X, R, Q implies for all X, R, P. Okay, so this tells us that we can, that if we have something that looks like this, we can say it follows from something like that. So if we have a for all with we have a for all implies a for all, we can say that that follows from this kind of for all. Well, that's what we have. We have a for all implies a for all. So that matches this bottom part here. So we can say that this follows from for all X R, and that part's fine because we've got, you know, R, 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 none of that's different. And now what do we get here for our implication? We get whatever is in the body here implies whatever's in the body here. So in that case, that's going to be not P implies not Q. Okay? And that's using 9.12. Monotonicity of for all. So that gets us to here. Now this is, and notice that the follows from, that's a good thing because we started with the right-hand side and we're saying the right-hand side follows from the left-hand side. So we expected a follows from somewhere on the spine. So the fact that we got one here, that's actually a good thing. We're like happy campers about that. And so now we've got to, we're left trying to get this part to match the left-hand side here. Well, for all X matches, R matches, we've got Q implies P here, and we've got not P implies not Q here. But we can make those match exactly using 3.61 again, because it says not P implies not Q is Q implies P. And so that one step will get us where we want to be. So I'm going to sneak that in down here on the bottom. So 361 contrapositive again, contrapositive. And that's going to give us for all X, R, Q implies P. That matches the left-hand side, and we're done. Whee! So that's not too bad. I think the tricky part there is recognizing that 912 is where we want to go. And again, the naming of the theorem and the structure is a hint that that's a reasonable thing to do. And then it's a matter of converting these for alls or R exists into for alls and we end up doing contrapositive in this case, whereas in the previous case we used De Morgan to do all that flipping around. Here, contrapositive did the flipping around for us. Oh, I guess we used generalized De Morgan twice at the beginning to turn the exists into for alls, so that was important. Once we'd done that, then it was all contrapositive and 9.12 to get us to the end. So, questions?
Can you go over the 912 manipulation again? I'm just not quite following.
Yeah, totally. I think that's actually a pretty confusing part of it. So, one way to read 9.12, let me go up here and we'll get another color. Let's try this. So one reading of 9.12 could be, like the way it's written, it says that this implies the right-hand side. But we could also read it as saying that for all x, r, q implies for all x, r, p imply or follows from for all x, r, q implies p.
Okay.
That we can read it as this gives us that, but could also read it as the right-hand side comes from the left-hand side.
Mm-hmm.
And that's always a legal way to read an implication like that. And because what we have here matches pretty well, right? We have for all x are a thing implies for all x are another thing. That follows from for all x are right-hand side thing. Oh no, sorry, left-hand side thing, q implies right-hand side thing. So in this case, not p implies not q.
Gotcha. Yeah.
Does that make sense?
Yeah, that makes a lot of sense. Yeah.
Yeah. But that's actually, I think, not an easy step to see. I think that I think the first thing in this proof is figuring out that you want to even use 9.12. And again, the naming and stuff, it provides a hint there. But then once you've figured that out and you get down to here, you've got to be like, and how can I use it? It might have been easier to see in some ways if we had kept if we'd been writing the whole thing. We would have written a lot more because we would have written this unchanged blah, 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 on the left-hand side over and over and over again. But then we would have gotten down at the bottom, we would have literally just had a copy of 9.12 just written out at the bottom. And so it would have matched exactly. By only starting with the right-hand side, I've at some point got to have a follows from happen. And that happens here at the 9.12 step. But that may not have been as obvious because I had this following from that. Does that help with that, Cole?
Definitely.
Cool. Other questions? Okie dokie. Not hearing any. We've only got a few minutes left. I think starting the translation stuff now would not be a wise use of 2 minutes. Are there any other questions about the examples we've done today, the quiz, the homework that's coming up, the timing of the exam? Does anybody have any questions about any of those things? Okay, not hearing anything. Go have a wonderfully exciting weekend trapped indoors. Be safe, wash your hands. And hopefully things will go okay on the homework. If you've got questions over the weekend, I'll probably be on the computer a fair bit because my life has now been reduced to one room mostly. And within 10 feet of this computer that I'm sitting at right now. So feel free to send me questions. or post questions on Slack. If you've got questions about work that you're doing, it's useful to like take a picture of it and share that in the email or the Slack message so I can see exactly what you think is going on. If it's sort of like I don't know how to even start problem X, right? Then that you could just say, I don't know how to start problem X. But if you're sort of doing something, you're like, I'm not sure if this step is legal, or I'm not sure if this proof is legal, or I got to here and now I don't know what to do. If you give me sort of something fairly precise, like a photograph of your work, then it's easier for me to provide answers. But I would definitely be happy to try to help out. Oh, and I haven't posted the link. I think you have something in your email, but I meant to post the link on Slack and Canvas. I'll try to do that right after class. But the drop-in tutoring sessions that used to be in the Lopez room, Sunday, Monday, Tuesday, and Wednesday, maybe even Thursday, I don't remember all the dates now. That has been moved to online Zoom Fun. So there is a TA who would be available to answer questions about this class in a Zoom session that's being paid for by Office of Academic Success using your tuition dollars. So you should take advantage of it. And they're now doing this online instead of doing it in a physical room. And like I said, I think you've got an email with the links, but I'll post the links on Slack and Canvas as well, so that if you want to like step into one of those Zoom rooms, you certainly can, and hopefully everything will be good. Okay, anything else in the 0 minutes remaining? Coolio, go have an awesome week, and I will see everybody Monday, hopefully hear from some of you over the weekend, and thanks a lot. Ciao.